Hello, welcome to Lab 5. Today we're going to be dropping a penny from the Empire State Building. So the first thing we'll be exploring is the idea that a penny will be dropped from the top of the Empire State Building, and we're going to see if this does any damage, right? Because there is a common conception that a penny dropped from the top of the Empire State Building could, hurt someone or break stuff, and we're going to be analyzing that idea, seeing if it's true. So first we will determine the speed of a penny by the time it makes it to the street. And this can be determined by predictions based on the forces interacting with the falling penny. For example, gravity and drag. And we'll see how a penny moving at this speed could affect people, objects, and others at the street level. Important concepts will be Newton's second law, momentum principle, and impulse momentum theory. And then of course, we'll be modeling the fall of the penny with glow scripts. So our first step is going to be to resolve the forces acting on the penny. So the force of gravity on the penny is just the mass of the penny, 2.5 grams, times the gravitational constant. And it's obviously going down in the y-hat direction, the negative y-hat direction, that is. And then next we're going to need to consider the force of drag on the penny. It's basically just all these constants multiplied together. But the important part is that the drag force is a function of the velocity, right? Because the velocity is going to be changing as the penny is falling and speeding up. So it's actually going to be, the force is going to be all the product of all the constants times the velocity squared. And obviously that's going to be in the positive y-hat direction, as it will be opposing the motion of the penny. So the net force is going to be mg hat, or mg plus the drag force. That's the net force. And then here we have the initial conditions. The height of the Empire State Building is 381 meters above the ground, which is actually not the actual height of the building, but it is the highest point at which a person can stand. I think that's the observation deck height. And then we're going to use the computational model to update the position of the penny from this initial height of the observation deck. And we'll drop the penny, not throw it, so it will begin at rest and just follow regular free fall, right? So time to do the simulation. So I used the starter code from lab 2 as it was pretty similar. Changed the initial conditions to account for the height of the Empire State and the penny's mass. And then I calculated the drag force. One thing I did have to do was multiply the drag coefficient that I found by 1,000. I'm assuming that's because something with the units, there's probably something in kilograms and had to just be converted to grams. And then there's the updated position. We updated the position using the position update. Nothing crazy there. And then here we see that terminal velocity was reached after 3 seconds about, and terminal velocity was 11 meters per second. And it took 35 seconds for the penny to land. But what's really important is this final velocity. So we can use that in the following slide. So here we can find out the force of the penny by the time it gets to the street level. The one thing here on this slide is the duration of impact, which I really just had to estimate based on how much force I felt was reasonable, because the duration of impact will kind of change based on the object. So yeah, I just went with 0.1 seconds because I feel like 275 newtons of force is pretty reasonable. And this force is not enough to fracture a human skull, not enough to crack a windshield, really not enough to do anything that would cause any type of harm that we should be worried about. So it's safe to say that we squashed this myth, and a penny drop from the top of the Empire State Building will be pretty much harmless. So to conclude, we use physics in order to predict the motion of a penny drop from the top of the Empire State Building. We discovered that the penny eventually reaches a terminal velocity of 11 meters per second, and the force that penny would have would be around 275 newtons, which is not an amount of force that will cause a ton of damage. Thank you for listening.